Welcome to Linear Algebra. We are going to start with a review of systems of linear equations, so hopefully everything in this first video is review for you. So we are familiar with solving systems, and you've solved a system like this before, but it probably looked just a little bit different because it might have looked like x plus y equals 5 and 3x minus 2y equals 10. So this is a linear algebra class, and so we're going to have quite a few variables, and so instead of x, y, z, and then now do I start over at a, we're just going to use x with a subscript because then we can have just as many variables as we want. So that will be the only real difference, or the two differences I guess, is instead of x and y we're using only x's, and we're going to have a bunch more variables than we're used to. Now we're going to be using matrices quite a bit, and maybe this is the first time you've dealt with matrices, and hopefully not. But there are two matrices you need to be familiar with. The first is the coefficient matrix. So if I'm looking at the coefficient of x1 and the coefficient of x2, notice those are both ones, and those are my entries here in the matrix. And then of course 3, and don't forget the sign, -2, and those are the four values in my coefficient matrix. So notice in the coefficient matrix, I use only the coefficients and I don't use the solutions of 5 and 10. An augmented matrix has the coefficient matrix on the left side, has some kind of divider here, dotted or solid line, though I will tell you in the textbook that we're using for this course, they often don't have a divider. I want you to use a divider. And then on the right side, of course, this is the solution set of 5 and 10. Now, we hopefully are very familiar with being able to solve the existing system because I made it a nice and easy one, and I only have two variables, so I feel like I was being pretty easy. So let's take a look at how we would solve this, not using a matrix, and then we'll talk about what that looks like with a matrix. So if I were solving this, remember that I'm going to solve by elimination, and what that means is I want to be able to add these two equations together and for one of my variables to eliminate, which means I need the same coefficient but the opposite sign. So I'm going to choose to take this entire equation times 2, because that's going to give me in this column a positive 2x2 and a negative 2x2. So if I add these together, I get 5x1 plus 0x2 equals 20. And of course you don't even have to write the 0x2. And then by division I would know that x1 is equal to 4. Now, before I solve for x2, let's take a look at this augmented matrix of 1, 1, 5, 3, -2, 10. And I want to think about what we just did. What we just did is we multiplied that first equation by 2, and then we combined the two equations. So that's what I'm going to do here, and I'm going to use some notation that I'm not really going to explain yet. So in a future video, I think the very next video, we're going to talk about this notation. But for now, just know that I took 2 times row 1 and I added row 2 to it, and I'm going to make this my new row 1. And again, don't get too caught up in the notation. I'm going to go through that in very great detail in the next video. But essentially what I'm doing is I'm doing exactly what I did over here, but I'm doing this in a matrix. So I'm taking 2 times this row, I'm adding it to the second row, and then I'm going to put that in row 1. So what is that going to look like? Row 1 is taking 2 times 1 plus 3, which is 5, and then 2 times 1 plus -2, which is 0, and 2 times 5, which is 10, plus 10, which is 20. And this, nothing happened to. So I want you to notice I have 5x1 and 20, and I have 5x1 and 20. So this is kind of how it's going to relate. Now, what would I do next? Well, what did I do here? I divided by 5 and divided by 5. Well, that's what I'm going to do. Now, again, we're going to spend some time talking about what an OK row operation is, but essentially what I'm going to do is I'm going to take a fifth of row 1 to make that my new row 1. So it's like dividing by 5 but multiplying by 1/5. So I get 1 and 0, and of course 20 divided by 5 is 4, and nothing has happened here yet. So now what's going to happen is I want to solve for x2. Now if I'm doing a system of equations, I would probably take the x1 plus x2 equals 5, replace x1 with 4, and find that x2 is equal to 1. So how am I going to do that in a matrix? Well, let's take a look. I want to, before I do that, I want to just note that what does this transfer back into? This means x1 plus 0x2, whoops, forgot my x, plus 0x2 is equal to 4. That's exactly what that translates back into. And so really what I want is I want this guy to be a 1 and this guy to be a 0. So how am I going to make that a 0? So let's focus on the 0 first. And again, if you're like, what is she doing? We're going to spend a lot of time developing an algorithm for how best to go about doing something like this. But just stick with me for now. I'm going to take -3 times row 1. I'm going to add row 2, and that's going to be my new row 2. So notice row 1 is staying exactly the same, and row 2 is now -3 times 1, which is -3, plus 3, which is 0. And then -3 times 0, which is 0, plus -2 is -2. And then -3 times 4, which is -12, plus 10, which is -2. Now what? Well, now I need to get this guy to be a 1. So how would I do that? I would take -1/2 of row 2 to be my new row 2. So basically I'm just saying divide it in half and change the sign. So my first row remains unchanged. My second row is half of 0 is 0, 1/2 of -2 is -1, and then of course I change the sign. And then again, half of -2 is -1, and I change the sign. And so this is my final matrix. So what does that tell me? Again, this guy translates into 1x1 plus 0x2 is equal to 4, and 0x1 plus 1x2 is equal to 1. And of course we know that we don't need these, so this is just x1 is 4 and x2 is 1, which is exactly what I found over here. Probably a little bit easier, but again, we're not going to be solving these nice easy systems where I just have 2 variables. I'm going to be solving for 5, 6, 7, 12, 15 variables, and believe me, using the matrix way is much, much easier. Let's talk about some terminology together, just so that when we are talking about something, we're all talking about the same thing. First is a linear equation. A linear equation is simply an equation that can be written as a1x1 plus a2x2 plus a3x3, etc. Where obviously a1, a2, all of those values, and b, which is the solution, are real or complex numbers. And so that's just a fancy way of saying, hey, you've got a linear equation like we used to have with, y equals mx plus b, just a different form. So it's basically a standard form equation where we have variables and coefficients equal to some value. A system of linear equations would be two or more linear equations that use the same variables. A solution is a list of numbers that makes each equation in the system true, so that's important. It's not just making one of the equations true or two of the equations. However many equations we have, we should be able to substitute those values back in for x1, x2, x3, etc., and make the equation true. And the solution set is the set of all possible solutions to a system. So it could be that you have one solution, or it could be that you have many solutions, or it could be that you have no solution. So let's take a look at what that might look like. There are three types of systems, or two if you're talking about just consistent versus inconsistent. So if you have a system that is inconsistent, essentially what that means is that you have no solution. So I've tried to make this very easy. This is obviously just using two equations, and that's not what we're normally going to do, but it does help to have a visual. Essentially I'm saying, hey look, I've got two equations and they are never going to touch each other, and therefore we have no solution. If I have a consistent system, then I'm going to have at least one solution. So it might be that I have exactly one solution, and that's going to be some ordered pair or ordered triple, or however many values I have. So if I had 5 variables, then I'm going to have some value for x1, some value for x2, some value for x3, some value for x4, and some value for x5, that when I replace those values into those 5 equations, it makes each of those equations true. Or I could have infinitely many solutions, and that happens quite often. Now again, with two equations, essentially what that means is we've got two lines, and you can only see one of them because I'm not a magician, but basically I've got two lines. The other one is stacked directly on top of this one, which means everywhere that line is a solution to both equations. So I generally like to put a practice question somewhere in each video or each couple of videos. And typically I'll write them in blue, and that just means to you that I'd like you to solve this on your own. So I'm asking you to use elimination. Now if you are comfortable with matrices, you can certainly use matrices to solve. But I'm going to just use straight up elimination. So what I would like you to do, and notice I've cheated down here. I've already provided you with a solution, and that's just so when you get to the end, if you get something other than 29, 16, 3, you know you've made an error somewhere. Don't you wish we always had a key like that? But I'd like you to press pause and work through this entire equation using elimination, because now this is obviously a little bit trickier. If you don't feel ready for that because you haven't done this in a while, it's okay to just pretend that you pressed pause. But I'm going to go through it in just a moment, but I would like you to press pause, try the equation, solve, and hopefully get 29, 16, 3. All right, so let's take a look. What I like to do when I'm solving with elimination is choose the variable that I want to eliminate. Now this decision was sort of made easy for me. I'm going to use this equation because I already have only two variables. 2x2, oops, not x squared, 2x2 minus 8x3 equals 8. And what I'm going to do is I want to combine these two to also get rid of the x1 variable. So I'm going to take 4 times this equation, and I'm going to combine it with this equation. So I'm going to do this mentally just so that I don't take up all of the room here. So if you're not so good at mental math, go ahead and write out the 4x1 minus 8x2 plus 4x3 equals 0, and negative 4x1 plus 5x2 plus 9x3 equals negative 9. So it's totally fine to do that. Again, we're not going to be using this method very often. This is just to get us ready for all of the matrices that we will be using. But essentially what I'm going to do is add these together and note that the x1 is going to eliminate. And then I'm going to end up with negative 8 plus 5, which is negative 3x2, and then 4 plus 9, which is 13, x3, and 0 plus negative 9, which is negative 9. So again, write those if you need to, otherwise just do the mental math. Now what I want to do is eliminate again. So I've eliminated x1. Now I need to eliminate either x2 or x3. I'm going to choose x2. So I'm going to take this equation. Oh, I don't like purple. That's not bright enough. I'm going to take this equation and multiply it by 3. And I chose 3 because 3 times 2 is going to give me 6. And that gives me 6x2 minus 24x3 equals 24. And I'm going to take this whole equation and multiply it by 2 because 2 times negative 3 is negative 6x2. And then 2 times 13 is 26x3. And 2 times negative 9 is negative 18. And I'm going to combine those together to end up with 2x3 equals 6. Divide by 2 to get x3 equals 3. And I'm feeling pretty good about myself because so far I'm right. Now, what do I do with the x3? Well, I have to plug it back into an equation to solve for another variable. Now, I don't want to go all the way back here usually, because usually I've got 3 equations with 3 variables. So I'm going to choose one of these equations, and it doesn't matter which one. So I'll go ahead and choose the 2x2 minus 8x3 equals 8. And now I'm going to replace x3 with 3. And so I get 2x2 minus 24 equals 8. I'm going to add 24, so 2x2 equals 32. Divide by 2, I get x2 is 16. And now I feel like a genius because, again, 2 correct. And then I'm going to finish it out with taking both 3 and 16 and plugging it back in somewhere. So I'm going to choose that first equation, x1 minus 2x2 plus x3 equals 0. I'm going to replace x2 with 16, x3 with 3. I get x1 minus 32 plus 3 equals 0. Minus 32 plus 3 is minus 29. Add 29 to each side. I get x1 is 29. And yay. So again, we're always going to write our final solution as an ordered pair or ordered triple in this case. So 29, comma, 16, comma, 3 is my final solution.